So let's talk about paint chemistry and what the TDS says. This has been very controversial lately with the drying versus curing. So let's dive into this a little bit. Curing in chemistry. These are chemicals we're using with clear. Curing is a chemical process employed in polymer chemistry and process engineering that produces the toughening or hardening of a polymer material by cross-linking the polymer chains, even if it is strongly associated with the production of thermosetting polymers, which you've heard me say before. Thermoset is a product that is mixed together with an activator. The term curing can be used for all processes where a solid product is obtained from a liquid solution, just like paint. So when these products cross-link, this is what happens. This orange chemistry here, this is not the chemical makeup of clear, but in general, the orange is your clear and the yellow is your hardener. And when things cross-link, they are driving together and binding as one. So curing versus drying, all these parts in here that are painted are cured within anywhere from 8 to 16 hours, depending on the clear you're using, the products you're using. So if we look at the TDS, and this is where TDS sheets can be very deceiving. If I look at this TDS sheet, air dry 12 to 16 hours. What that means is air dry to deliverable, as they say in the collision world. It's deliverable in 12 to 16 hours, which means I can touch it, I can buff it, wouldn't recommend it, but I could. And if I put this back together and give it back to the customer and he takes it out and washes it and uses the vehicle, it will be fine. That does not mean that it's dry. This is air dry. This is where it's deceiving. Air dry, 12 to 16 hours. That means I can put it together, do all the stuff. It's not dry. There's still solvents in this. It is cured in 12 to 16 hours. Infrared baking, when we get into the baking of things, everyone says, why don't you guys bake in the booth? There's a lot of reasons we don't bake in the booth, especially when we're stacking 5-6 coats of clear. We are modifying flash times, which is another thing in here that, okay, application of 5700, 2 to 4 wet coats with what they recommend, a 5 to 10 minute flash time. If I use a 5 to 10 minute flash time and I'm putting 4 coats on, in between my second and third and my third and fourth coats, you're gonna get solvent pop. If you give it 5 or 10 minutes and you stack 4 coats like that, it's gonna take longer to actually dry. You're gonna get solvent pop almost for sure, and probably runs. When we're stacking clear, 4, 5, 6 coats of clear, we're modifying flash times. Every coat we put on is a longer flash time than the last. Our flash times can vary anywhere from 15 minutes up to an hour when we're stacking clear. What else do I want to talk about? So when we talk about curing with a liquid activated product, curing can be induced by heat, radiation, electron beams, or chemical additives. This basically means there's multiple ways things can be cured. There's primers that are a UV cure that do not have a hardener because they don't need it, because they are UV cured. This needs a hardener because it is a thermoset product. It needs to chemically bind and cross-link and cure. Once that happens, this is not dry. If I take this tailgate, which was sprayed a few days ago, if we let this sit in the sun for 3, 4, 5 days and let it bake, this is gonna get way peelier because you are losing mass as your product is drying. There's solvents coming out, you're losing mass. That's why it becomes peelier. Your film build, same as in TDS sheets, it tells you wet film build, dry film build. There's a difference. When it's dry, it's thinner than when it's wet. When it's actually totally dried, it's gonna be a lot peelier. So products that are a 1K with no activator, that are not a UV cure, they are thermoplast, which means if I use something like a Buzz Bomb black spray paint, I could leave that sit out in the sun dry for years. And if I come back with some lacquer thinner, I can wipe it right off because there is no chemical curing process. So when we talk about baking, there's a lot of different ways to bake things. A lot of people ask us why we don't bake in the booth, and there's a few reasons for that. You're way more prone to get solvent pop, especially when you're stacking, 3, 4, 5, 6 coats. You're way more prone to get solvent pop, and as this clear is drying, we want it, when we're stacking lots of material, you don't want to force it to dry. You want to let it just dry naturally. We usually let it dry at least a day naturally before we put it in the sun, to where that product is cured but not completely dry. So the whole point of us putting these panels in the sun or using an infrared light, which is more or less the same thing. The sun is better because it's a bigger area. You probably get a little more heat on the entire panel at one time with the sun. But when it's wintertime or raining outside, sun's not an option, then we use the infrared light. According to the TDS sheet, I can infrared bake this clear right after I spray it. 5 minutes at a half bake, 9 minutes full bake with an infrared light. I have tried that when I was in a hurry in the past on collision jobs, things like that. If I infrared this, if I take a bake light in the booth and infrared this, say 20 minutes after I'm done putting my last coat of clear on, it is going to solvent pop. No question about it, because it's just way too much heat, way too fast for a fresh product. I don't know why they even tell you can infrared bake this to actually cure it and dry it in the booth. Not recommended. TDSs can be very deceiving, and sometimes you gotta know how this works. If you're gonna do work like this where you're trying to stack clear and you're going for the best outcome, you have to understand how these products work. The TDS sheet is not gonna be anywhere remotely close to what actually happens when we're doing this process, trying to do a nice restoration type work. This is not collision work. This is all based off collision work. Back to baking, force dry, which means booth bake. They say 40 minutes at 140 degrees. If I stack, say I put 4 or 5 coats of clear on this, and I give it maybe a 10-minute cycle, and I turn the bake on the booth, I am almost for sure gonna have solvent pop, because what's gonna happen is the air is 140 degrees. The panel is not 140 degrees. The air going around it is 140 degrees. It's gonna heat the clear from the outside in. It's gonna dry the outside before the inside is dry. It's gonna start curing the outside much faster than the inside. When that happens, those solvents will get trapped and they can't come out like they're supposed to. If I do 2 coats, I might get away with baking this in a collision world, sure. 4 or 5 coats, not a chance. You're gonna have solvent pop, and I've had it in the past on collision jobs that I've baked, where it looks great, you hit the bake, you come back in, runs. When you booth bake, that clear is getting much more liquidy as it's kicking, as it's curing, it's getting much more liquidy. The viscosity of the clear is going up a lot, and you're gonna get more runs and sags and things like that. So if you're stacking clear or trying to get the best outcome you can, any more than 2 coats of clear, no reason for a booth bake. Let it dry. This is not a race. This isn't collision work. This stuff ain't leaving tomorrow. Everyone that thinks that when we put these panels out in the sun and we're infrared baking or baking in the sun, that we're still curing these panels, I'll finish with this question. When it rains outside and the water evaporates, is it curing or is it drying? This is the same concept.